Welcome everyone to another video in which we are going to solve problem number 18 from chapter 2 force vectors in the book of engineering mechanics written by R.C. Hibbeler, the statics part. This problem is very similar to one which we have solved previously, problem number 17 actually. In the problem number 17, we were asked to determine f dash of f1 and f2 first, and that f dash was added with f3 to determine the resultant of these three forces. But in this case, it's a bit different. Here we are being asked to determine f dash of f2 and f3 first, and that f dash will then be added with f1 to determine the resultant of these three forces. So let's solve this problem taking the body on which these three forces are acting. So we will take F2 and F3 force first to have F dash. So F2 is 20 Newton, makes an angle with 20 degree with negative y-axis. F3 is along the positive x-axis. So in order to have its magnitude, I mean F dash, we will use cosine law. So f dash would be then equal to, in under root, f2 square plus f3 square plus 2f2 f3 cos of angle between them. Let's say it's alpha. So angle between them is actually 20 plus 90. You can see 20 is this angle and this angle is 90 actually, so makes it 111. So just put the value here. Angle I just tell it's 110 degrees. So when you are going to solve it, you're going to get the f dash, the magnitude of f dash as 47.07 Newton. Now in order to have f dash and f1 to be added, in order to have resultant, we need to know the direction of this f dash. So for that again we need sine law. We will keep if one force at its same position, and we'll displace other force by taking the tail of that force with the head of the first force. So I'm keeping F3 at the same position, but I'm displacing now F2 force by taking the tail of F2 with the head of F3. And now the closing side would be the resultant, which we just have calculated, that is F dash actually, which is 47.07 Newton. Now in this triangle you can see we can determine this interior angle. If this is 20, so this will be 70 in order to make 180 from here to here. So 20 plus 70 is 90. That is actually the negative x-axis with the negative y-axis, or you can say simply x and y-axis. The total is 90. So if this is 20, then this will be 70. So then we can have one side which is 70. The opposite side is actually f dash, which is 47.07, which would be equal to, actually we are interested in determining this angle because this angle is the angle of f dash, the direction of the f dash. So sine of direction of f dash divided by the opposite side, which is f2, that is 20. So this unknown angle will now be equal to 23.53 degrees. So this is 23.53. Now we know the magnitude of f dash and its direction. We will use that information with f1 to have the total resultant. So for f dash, what we have its direction, its magnitude. Now where is f1 force? F1 force is here, and we are not directly being given with the angle, but we are being given with this right angle triangle. From here we can determine this angle by using 10 formula. So 10 of, let's say, alpha is 304. Alpha would be then equal to 36.87. so this angle is 36.87. Now we can determine the resultant f(r), the resultant of f dash and f1, using cosine law. So f1 square f dash square plus 2f1 f dash cos of beta, let's say, the angle between these two forces. That's from here to here, this angle. So this angle can be calculated, and it's quite easy. So this angle is actually 90 minus 36.87. This angle from here to here is 90, and from here to here is 23.53. So we simply add all these. The resultant fr would be then equal to, we will just put the magnitude of f1 and f dash. Now cos, we will have some calculations, that is 90 minus 36.87 plus 90 plus 23.53. so when you do this calculations, you're going to get the angle as 166.66. so the resultant from here would be equal to 19.17 Newton. This is one of the answer. That's actually the magnitude of the resultant of these three forces. And if you remember in our previous problem, which was problem number 17, we got the same value because there is nothing being changed, but the process has been changed only. Now let's move on for the direction. For direction, again we are going to use the sine law. We'll keep one force at the same position, we'll displace the other force. So I'm displacing F1 force. So this closing side will now be equal to the resultant force. We just have calculated that. That is 19.17 Newton. So we know few of these angles. So previously we know the direction of f1, we also know the direction of f dash, therefore we can determine this interior angle. So for that you have to be very detailed in this. We have the value of f dash with the positive x-axis, that was 23.57, so this will also be 23.53, and this one, we know the angle for f1 with the x-axis that we have previously calculated as 36.87 if you see your previous calculations. So with that's with the x-axis. If we want with the y-axis, we simply subtract from 90. So on subtracting, we are going to get the angle as 53.17, sorry 13, as this angle. So if you want this angle, then what we are going to do, you can see the total angle is 90. From here to here it's 90. We subtract 23.53, we will also subtract 53.13. so this will then give us this interior angle. Why we are doing this? Because this is going to be used in the sine law. So sine of this angle which you are going to put here will be divided by the magnitude, which is 19.17, the opposite side, which is f4. Now we are interested in this angle because this is the angle which will help us in determining the direction of f4. So sine of let's say x degree, the opposite side is f1, which is 30. So from here we can have the x degree, which is if you calculate, you are going to get that as 21.16 degrees. Now you know that this f dash makes an angle of 23.53. So if you subtract this 23.13, then we are going to get the angle this resultant force is making with the x-axis. So 23.53 subtracted by 21.16, so you are going to get the angle as 2.36. So that's the direction of the resultant force. We have determined its magnitude, which is 19.17. The direction with the positive x-axis is 2.36. And if you recall the problem number 17, we also got the same value, the same direction as well as its magnitude, because the forces are same but the process is different. In problem number 17, we determined the resultant of f1 and f2 first, and then that resultant was added with f3 to have the total resultant. But here the process is a bit different. Here f2 and f3 forces are first added. The resultant is added with f1 to have the resultant of these f3 forces. That's all from this video. I believe you have an idea how I'm doing all these calculations. If not, then please let me know through the comment section. I'll try my level best to get back to you. That's all from this video. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.